Alright, this is a quick recording for LaBoss509, who asked this question. Now this was a really complicated question, and I'm not 100% sure I have this worked out correctly, especially because you say round to the nearest minute, and my answer is coming out to be seconds. So, you said you weren't even sure really where to get started, so even if I'm making a mistake somewhere, maybe some of the nonsense I'm about to show you will be helpful. But first of all, I'm kind of hoping that it's really supposed to be round to the nearest second. Otherwise, it doesn't make sense according to my calculations. Okay, where I am, it is almost 2 a.m. when I happened to be checking my messages. I was just getting ready to go to bed. So please forgive me if I'm a little incoherent, and I'm going to try to get through this quickly, more quickly than I normally like to work. But you know, our brother's got to get to bed at some point. All right, buckle up. Here we go. It's complicated. All right, brace yourself. So a plane takes off from the ground at 150 miles per hour. Okay, so here's the situation. So we have this plane. Well, this is the ground. And the plane takes off from the... Whoa, what happened to my ground? Will it come back? No. All right, let me redraw it. The ground is here, my friend. This is the ground. Okay. Plane takes off from the ground at a 10-degree angle. So fine. The plane takes off at a 10-degree angle. So, alright, and it gets to, let's say, this point right here. And so this is 10 degrees. And then it makes an adjustment, and it keeps flying at the same speed, but it changes to an 18-degree angle. Okay, so let's just throw in here I'm going to put this line here parallel to the ground still. Alright, because I'm going to need that to form my 18-degree angle. Alright, so this is going to be a little bit bigger. You know, obviously this is not to scale. Alright, this is not a good 18-degree angle. But anyway, so this would be 18 degrees right there. Now, ultimately, we're going to get to this point right here, which is at 30,000 feet. Okay, I'll just make that black. So we want this height to be 30,000 feet. Alright, so that is the basic picture of the problem. So let's break it down, and it's a little bit crazy. So the plane takes off at 150 miles per hour. And then they're talking about 6 seconds. So here we have two different units. We have hours, and then we have seconds. And then at the end, they want to know how long it's going to take rounded to the nearest minute. And I went ahead and just changed that to seconds because the way my numbers came out. So basically, instead of hours, we need seconds. Okay. So I'm going to take this miles per hour. Oh yeah, and also we're talking about feet. 30,000 feet. So our answer needs to, we need to convert, instead of miles per hour, we need to convert this over to feet per second, because those are the units we're going to ultimately be dealing with. So off to the side somewhere, okay, down below, I'm going to convert 150 miles per hour over to feet per second. Okay, so I have 150 miles per hour. So here's how I do unit conversion. Alright, so miles, 150 miles per every 1 hour. Okay, that's what we started off with. Now I want to convert this over to feet and seconds. So here's what I do. I'm going to multiply by some fractions here. Now, I don't want miles, I want feet. So I happen to know that there are 5,280 feet in 1 mile. Alright, that's a fact that I memorized back in high school. So you could Google that if you did not know that. So I'm going to use these two numbers and stack them up, and I could put either miles in the top or the bottom. It doesn't matter, except I want to get rid of miles, so I'm going to make sure I put miles on the bottom. Okay, so 1 mile. I'm putting it on the bottom so I can cross out the miles. And so that's going to leave 5,280 feet in the top. Okay, so watch what happens to the units. Alright, miles cancel out. So right now, all I have left, I have feet per hour. I have feet per hour. But I don't want hours, I want seconds. Alright, so I need to get rid of hours also. So I'm going to keep going, and I'm going to do another one of those fractions that I'm going to multiply by. So I'm liking feet, so I'm not going to bother that. But hours. I want to get rid of hours, so I'm going to put hours in the top, and I want seconds, so I'm going to put hours in the top and seconds in the bottom. I know that 1 hour is equal to, oh, you know what, maybe this is what I did wrong a minute ago, because I think I put 1 hour and then I put 60 seconds. I think that's what I did wrong, okay? So maybe it will be minutes. Anyway, alright, so I'm off the rails already. So I know that 1 hour is equal to 60 minutes. Okay, so far that means hours are gone. Now I have feet per minute. I have feet per minute. Okay, but right here at the beginning it says after 6 seconds the plane makes this adjustment. So I'm going to have to keep going and get this to seconds for now. I might change back to minutes because it, the problem did say minutes before. Let me change it back. Maybe it'll work. Anyway, so the hours cancel out. Now I have feet per minute, but I'm going to keep going and convert this over to seconds. Okay, so I don't want minutes, so that means I'm going to put minutes up here so they will cancel out, and I will put seconds down here. So I know that 1 minute is equal to 60 seconds. So the units cancel out. Alright, now, so look at all the units that canceled out, and what I have left, the only units that are remaining, in the top I have feet, in the bottom I have seconds. So when I put all these numbers together, the units will be in feet per second. So how do I put all these numbers together? Well, I am going to use my TI-30 XS multi-view to help me out, my handy dandy calculator. Okay, it looks like this. Let's see, can I scoot this over a little bit so it fits on the screen? Okay, let me just... Alright, I'm just going to have to remember it. So, I have these two numbers in the top, and in the bottom I have just 60 and 60. The ones don't really matter. Okay, so I just covered up one of the 60s, but just remember it in your head. So, I'm going to go into fraction mode here. So in the top, I have 150 times 5,280. Okay, and the rest is ones. In the bottom, I have 60, and don't forget I have another 60 over there. So in the bottom, I have 60. Whoa, I'm not in the bottom. Okay, in the bottom, I have 60 times 60. Okay, so that is 220. Okay, so what I have just figured out is that 150 miles per hour is the same thing as, what was it, 220? See, that's that sleepiness I was talking about. I can't remember for more than 5 seconds. Alright, so this is the same as 220 feet per second. Okay. So, why did I need that? Because it says after 6 seconds. So, this blue path that the plane is traveling, that lasted for 6 seconds. So, you know, this picture is all about lengths. You know, I have 30,000 feet. So, I need to know how many feet is this, how many feet is that. I need feet. So, if the plane travels 220 feet every second, if the plane goes for 6 seconds, okay, because this was a 6-second journey. Maybe I'll just put it right here. 6 seconds. Okay, that was a 6-second journey. So I just need to multiply this by 6. All right, 220 feet in 1 second times 6. That'll give me how many feet it went. So I'm going to go 220 times 6. Okay, so that is 1,320 feet. Okay, so this blue path that the plane took is 1,320 feet. Okay. Now, ultimately, we're going to need to know how high the plane was at this point. So I'm just going to drop a vertical line down here. Okay, this is 90 degrees. And we're going to use our trigonometry, you know, tangent, sine, or cosine, to figure out this height right here, the blue height. I'm going to call this height, what will I call it? I'll just call it H1, H sub 1. Alright, I'm going to erase some of this stuff. Okay, you saw how that worked. Unit conversion, it's a thing of beauty. Remember that from high school. Okay, Miss Anderson, Josie Anderson, teaching me unit conversion. Anyway, how am I going to find this basic trigonometry? From the perspective of the 10 degrees, the H1 is opposite, and this is the hypotenuse. Opposite over hypotenuse, we're talking about the sine function. So I could go like this. The sine of 10 degrees is, that's opposite over hypotenuse. So that's H1 over 1,320 feet. So if I want to solve for H1, I would multiply both sides by 1,320. Okay, that would cross those out. So that's going to tell me what H1 is, and later you'll see why we needed that. So here we go. So H1, I'm just going to put this in my calculator. 1,320 times sine 10. I've already got the 1,320, so I'm just going to go times sine 10. Alright, make sure we're in degree mode here, by the way. Okay, so that comes out to be 229. Okay, so I'm going to round. Should I round? I'll use one decimal place. What? Okay, 229.2. Okay, so 229.2 feet. Okay, so that's H1. Okay. So can I show that somehow? So we have 229.2 feet, and that's like this height from here to here. Okay, now, what am I going to do now? What am I going to do now? Okay, well, I've got another triangle over here happening. We got this pink triangle. You can rock it. It's awesome. Okay, just go ahead and draw that in a little bit better. So, you know, just like we found this part of the path, it will be useful to know the pink part of the plane's path, right? The plane went from here and then went like that. But to do that, we need this side of the triangle, okay? Not all the way down, but just the part up here. That's why we needed the 229.2. All right, if the entire height here is 30,000 feet, okay, then this part of the triangle is going to be 30,000 minus 229.2. So let's check that out. You know what, I'm just going to do that off camera because you can trust me. All right, so 30,000 minus 229.2. Okay, so that is giving me the following. Wonder, can I just scribble it right across here? This is 29,770.8. I better use a different color. I'll use this I'll use green. Okay, so what I say, we have 29,770.8 feet. Okay, that is this height right here. All right, I'm kind of switching up my colors, but 29,770. All right, fine. It's bugging me too. I'll put it over here. Okay, so that's that. Now that I have the 18 degrees and I have this green side of the triangle, now I can find the hypotenuse. Okay, using another trig calculation. So again, you know, this is opposite, and then this is the hypotenuse. Okay, I already used sort of an H for this over here, so I don't want to do it again. This is just going to be X. So if I want to find that right there, I'm going to use the sine function again. So sine of 18 is equal to opposite over hypotenuse. Okay, so that's 29,770.8 feet over X. Okay, now I don't know about you, you know, like you could cross multiply, you know, you could put a 1 under this and like cross multiply if that's your thing. But I taught my students a long time ago a little shortcut, because this comes up so often, that anytime you have, like, for example, P, look, let me just go like this. Say if I had 2 is equal to 30 over X. Anytime you have a situation like this, you can always swap the denominator with the number that's out here by itself. So I could swap these. I could put the X out here, and I could put the 2 down here. So that's an easy way of giving you, like, oh look, X is 15. You just switch them, and immediately x is by itself. All right, I mean that's a shortcut, but you know, if you cross multiplying itself is just another kind of shortcut, so it's valid. You know, Mr. Helpful Not Hurtful declares that this mess is valid. So that's what I'm going to do. So I'm going to swap these two things as a shortcut. So I'm going to put the x over here. Then I'm going to have 29,770.8 divided by sine 18. Okay, so I'm just going to put that in my calculator off camera. So I've got that divided by sine 18. Okay, and I'm getting 96,340 0.3 feet. Okay. So we just found this right here. So we found that this was 96,340.3 feet. Okay, so we made a lot of progress. We're almost done. Now, we want to know time though. So we've got feet, but we want to know time. How long did it take? So like over here, we know this is 6 seconds. So over here, like how many seconds is this? And if it's enough seconds, then we can convert to minutes. Okay, but for now, let's stick with seconds. So let's convert 96,340.3 feet into seconds. Okay, so let's do that. So here we go. So I've got this number right here. I'm going to try to convert it into seconds. So I've got 96,340.3 feet. Okay, now I'm going to do that unit conversion like I was doing before. Now, what do I know? What do I know? I'm trying to convert this into seconds. And here's the conversion. Right at the beginning, we decided that the plane is traveling 220 feet per second. So in this story, 220 feet equals 1 second, 220 feet per second. Okay, so that's just the conversion that we need, feet and seconds. So I want the feet to cancel out, so I'm going to make sure I put feet in the bottom. So 220 feet, all right, for every 1 second. All right, so I put those together because they're equivalent in this particular problem. 1 second equals 220 feet, 220 feet per second. You could put it either way. I wrote it upside down so that the feet would cancel out. So in fact, let's go ahead and show that. So feet cancel out, and so my only surviving unit here is now seconds, which is what I wanted. So I'm going to leave it like this for a second. So let's go ahead and do the math. The 1 doesn't matter, so all we really have is 96,340.3 divided by 220. So I'm just going to go divided by 220. Okay, and alright, so I just did this divided by 220. And what I got was 437.9 seconds. 437.9 seconds. Okay, so we are supposed to, they wanted us to round to the nearest minute. Okay, so now would be a good time to go ahead and at least round to the nearest second. So this is approximately 438 seconds. Okay, so we can certainly round to that. So let's write that down, 438 seconds. So we just found that this part of the journey took 438 seconds. Apparently Siri thought I was talking to her. Okay, so the first little part of the journey took 6 seconds. The second part of the journey took 438 seconds. Okay, so I'm going to switch to purple. So we had 6 seconds plus 438 seconds. All right, so obviously that's going to be 444 seconds. Okay, so that's how many seconds the entire trip took. But they wanted it in minutes, so let's do one last conversion. All right, so this is the third time I'm showing you this unit conversion thing, so thank you, Josie Anderson, my chemistry teacher, who drilled this into my brain. 444 seconds. We want to convert that to minutes. Okay, so I want to get rid of seconds, so I'm going to put seconds on the bottom. And I'm going to put minutes on the top because I want that to be left. And I know that every 1 minute is equal to 60 seconds. Alright, and so my units of seconds will cancel out. And my only surviving unit is, in fact, minutes. Okay, so if I go ahead and do this calculation, I will have minutes that I'm looking at. And I've got 444 divided by 60. So that's what I'm going to put in my calculator. 444 divided by 60. So divided by 60 gives me 7.4 minutes. That is 7.4 minutes. Okay. So they said to round to the nearest minute. So if I round it to the nearest minute, 0.4 is less than 5, so that would give us approximately 7 minutes if we round to the nearest minute. Wow! That was a lot. And I can't promise you that it is right, but hopefully, if it's not completely right, at least now you have a place to start. Before you were saying you just didn't know where to begin. I've given you plenty with which to begin, and it might even be right. Alright, so if anybody has any comments to make, suggestions, corrections, leave a comment in the comment section.